Good morning, students. Am I audible?
Good morning, sir. Yes, sir.
Vaishnavi, am I audible?
Yes, sir.
Okay. So today we are going to see the earlier bit plus the new bit, because yesterday in a hurry just we have wind up from the mobile that I tried to just deliver the session, but just take a quick review of that if you have gone through it. So definitely what today we are going to learn, so you will better understand. So in the first half, we will go with that the reference of yesterday's session, and which the title we have seen yesterday, that was configuration word related to PIC 16F877A. This is the model for which this chapter is totally dedicated. So for that configuration word, what it mean? Other than the normal operation, few additional functions or facilities it is provided for the pick. So to set them or to reset them, this configuration word, it is to be set in the code. Which code? That is program code, for which we are writing the application. For sake of applications, we are writing the code. So that code may be in assembly or maybe in C. But in each code, this configuration details must be there. So which are these configuration bits? Because the word is a combination of number of bits, that is size is of 14 bits. So which are these bits? So yesterday we have gone through. So just take a quick review of that, and then we will move towards the next demo, that is how it look like and how we can set the actual configuration bit through the software. So which software? That is compiler software. So which compiler software is freely available? That is what? MP Lab X. So that we can download and we can install, and through which we can write the code, or we can generate the hex file which is required for the simulation purpose, or to burn in the this actual pic when we are going to see it is in a physically. Got it? So this is what the background of this particular configuration word, and whatever we have gone through that. So yesterday's just PPT, and yes, so this is the main slide I want to just take a quick review on. So total 14 bit is the size of this configuration word, in which 3 bits are not used and the others are having just readout. I will also explain here that what the exactly the meaning and the working or the function of each bit to set or to reset. So as you can see in front of you, that is the, we will start from the MSB, that is bit number 13, that is pin number 13. So bit 13, it is reserved for CP. So what is this CP? That is code protection. So for which code protection? That is whatever we are writing in a flash memory. So that is the code. So with this bit, we can give the protection. That is, once you made this on this CP bit, so no one can edit that particular code which is stored in the flash memory. Is it? So this is the working of this CP. Then pin number bit 11, not pin. It is a bit 11, that is debug. So are you want to make it active, the in circuit debugger mode or not? So for that, this debug bit is there. Next to bit, that is 9th and 10th, that is for just making the memory write enable bits. So flash memory is there with you. program memory is there with you. So how much it is made available to the programmer, and how much it is protected or write protected, that is not usable by the programmer. So that can be decided with this 2 bit. So 2 bit means four possible combinations, and in which the one is telling that all the memory can be used by the programmer. So for setting that, these 2 bits are reserved. Then CPD, that is code protection bit again. For what? EEPROM memory. So as we know that in PIC, flash memory is also there, EEPROM memory is also there, RAM is also there. So three types of the memories are available in this particular PIC. So again, whatever you are writing in the EEPROM, so if you want to give some protection to that, that means not editable if you want to make. So this particular bit, you can make it on. So on means 0 or 1. So that already yesterday we have seen that. So if you have noted down, so you can use that in the coding. Bit number 7, that is for LVP, that is low voltage programming. So if you want to enable low voltage programming, that is serial program, if you want to make it enable, this pin we supposed to set it. Bit number 6 is BOREN, that is brownout reset enable. Brownout reset enable. So what is the purpose of this brownout that yesterday we have discussed? That is, if power fluctuation is there, so in that case, to save the this physical damage to the that particular PIC, this bit is going to be made it on. That means it resets or it stops the working in that way. That is the bone. Next one, that is the bit number 3, that is PWRTEN, that is power timer enable. PWR means power timer T and enable. So what is this bit is for? When from sleep mode peak comes into the normal mode, so it immediately cannot give the some burden on the this particular control system or the its ALU. So to make it into the normal mode, so some time it is given to that peak, and that time it is yesterday we have seen. So that is I think the fixed one for this peak, that is 72 millisecond. So to enable that, this particular pin is used. Power up means sleep mode to normal mode. Bit number 2, that is WDTEN, that is watchdog timer enable. So like that the brownout. So this is also the one of the way of resetting the PIC. So in which case reset the PIC? That is what? If software some malfunctioning is happening. That is, for example, I have given yesterday, that is if your program logic went into the infinite loop and you want to just come into the normal mode. So that time this particular watchdog timer, it will just check it out the what is going on in that peak, and if it feels that it is goes in a infinite loop, so it will resets the peak. So that decision it will take. So in that way, this is the more security features they have given in the PIC. And plus that is the last 2 bits, that is bit 1 and bit 0. So they are to decide that which type of oscillator you are going to use. So that programmer has to decide, okay, are you going to use the RC type or HS type or XT type or LP type. So what is this RC, HS, XT and LP? That depending on the frequency, crystal frequency, these 4 types are there or ways are there to provide the oscillator. So normally HS is being used everywhere in the code or at the practical time also this has been used. So this is short summary what we have seen yesterday for the configuration bit. So I hope now you understand that this is the configuration bits and how it has been there. And next we have that is, this is also very important. So whenever you are defining this particular configuration bits, okay, 38, okay, so whatever these bits are there, so how to set in the code, that means we have to write the command for that. So how to write the command for that? So this is what it is given here. So it should be start with the hash pragma. So that is the syntax. So if you can see here, the second point, that is the syntax, one of the configuration, it is been written here, that is hash pragma space config space the name of that configuration bit and the value for that. So pragma config f oscillator, that is equal to hs. So this is how we can set the configuration bit. So like this, all the 9 configuration bit has to define in each program whenever you are dealing with pick. Whenever you are dealing with pick, so pick means not all the pick for this particular 16F877. Hmm? So this is what the configuration is. So practically also we will see that how it will look like and what we can learn from this particular configuration bit. So through software, how to make it the this edit? So that yesterday we have seen this particular window, that is window, the path you can note down in either your notebook, window, pick memory view, and then configuration bit. So this is what the way how which we can edit these configuration bits. There is no need of writing the code by hand. Just go there and set 1 or 0 like that, and it will automatically add these configuration bits in the program. Okay. So after clicking on this type of window, it will appear. So if you can see the cursor, so here is that this particular list, it will appear for respective pick, which are the fields, the options, the categories, the setting, that the description is there, so that the programmer can set. So you can, if make it a little zoom and just check it out, the cursor option. So this column you supposed to make it on or off, 1 or 0. So that is required, that we can do for the configuration bit setting. So each one, that is boron, LVP, that is CPD, WRT, CP, WT, then F oscillator. So RC oscillator, that you can change from here. Once you have made these bits changes, after that, this is the additional it is given. If you chosen the LP oscillator type, so what the crystal frequency yesterday we have seen. Okay, low level frequency it will be there, then crystal, then hs. So normally we are going to use the hs, so either 4 megahertz or 8 megahertz or 20 megahertz. So like from that we can use for this respective. This is 1051 and Pratiksha Bosle is now okay. So HS is normally the mode which is used for the pick, and which frequencies are available for that, that is 4 megahertz, 8 megahertz or 20 megahertz. So that you can remember. So this is the what the zoomed I made it this, how we can set here that the HS off on in that way. So the observation thing is that the only 2 bits has to made it on and all other off. This is for your practical tips. फक्त 2 bits ह्या on करतात normally. So which are these? So that is first is that the brownout reset and watchdog timer. या दोन रिसेटच्या जे आहेत की ते फिजिकल डॅमेज पासून वाचवतात म्हणून. सो दीज टू बिट्स आर नॉर्मली मेड इट ऑन आणि एफ ऑसिलेटर एच एस सिलेक्ट करतात. तर असे तीनच फक्त चेंजेस इथून करायचे आहेत आणि नंतर यू सपोज टू क्लिक ऑन जनरेट सोर्स कोड टू आउटपुट. की ऑटोमॅटिकली ह्या बटनवर क्लिक केलं की हा जो तुम्ही चेंजेस केलेला आहे त्याचे कमांड्स ऑटोमॅटिक तयार होतात आणि तुमच्या त्या प्रोग्राममध्ये ऑटोमॅटिकली ऍड होतात. Got it? So this button is important after this making the changes. And it is look like this one. So this is what you can observe here. That is this configuration bits are set over here. That is hash pragma config f oscillator is equal to hs. म्हणजे hs हा घेतलेला आहे. WTE ऑफ केलेला आहे. PWRTE ऑफ केलेला आहे. बोरेन that is a brownout it is on. So LVP off, all other it is the off. It is written over here. Watchdog also they have made it over here off, but it should be normally on. तर अशा प्रकारे ऑटोमॅटिकली तुमच्या कोड मध्ये हे स्टेटमेंट्स ऍड केले जातात. ओके. अँड बिलो दॅट इफ यू कॅन ऑब्झर्व हिअर युअर ऍक्च्युअल कोड जो तुम्ही सी मध्ये लिहिलेला आहे. तर जसं आपण सी मध्ये stdio.h config.h ह्या हेडर फाइल्स ऍड करत होतो. सो इन दिस पिक xc.h ही हेडर फाईल आपल्याला ऍड करावी लागते. सो नोट इट डाऊन दिस पॉइंट ऑल्सो. पण हे पण कधी जर तुम्ही MP लॅब कंपायलर सॉफ्टवेअर वापरत असाल तर. मायक्रोसी वगैरे पण बाकीचे कंपायलर सॉफ्टवेअर आहेत ते जर वापरत असाल तर डिफरंट हेडर फाइल्स आर देअर. हा कोड तिथं नाही चालू शकत. लॉजिक विल बी द सेम पण हेडर फाइल्सची नावं तिथं त्या सॉफ्टवेअरमध्ये वेगळी असतील. ह्या सॉफ्टवेअर मधले फक्त आपण शेवटपर्यंत पाहणार आहोत. दॅट इज MP लॅब सॉफ्टवेअर. So for this xc.h, this is the header file which we have to insert over here. प्रोग्राम एक छोटासा आपण मागच्या लास्ट टू लास्ट सेशन मध्ये बघितला होता LED ब्लिंकिंगचा. सो टुडे ऑल्सो वी आर गोइंग टू फोकस ऑन दॅट. This is the simple and it's a first program we can say, that is the LED blinking. So through which we can learn the programming also. छोटेशा कमांड्स आहेत आणि लॉजिक सुद्धा सोपं आहे समजायला. सो दॅट्स वाय आय हॅव चोजन दॅट LED ब्लिंकिंग प्रोग्राम, हाऊ वी कॅन इंटरफेस विथ द पिक or how we can control with the help of pick. Okay, so this is what all the about configuration word what we have seen yesterday. So I hope you now got as from the yesterday's presentation. So now we will go for the actual where the program it was shown demo to you, and the Proteus and the MP Lab XDE. So both the softwares it is required. So this is MP Lab. I'm going to open that. So it will take a little time to get it open for initialization. So now it got open. So this is what the first home page of MP Lab IDE software, that is X, that is the version of it. In this way it appears. The background process still it is going on. Now it is stopped. Then where is this program? Now appeared. It's a little quite slower one. So this is the program, and in Proteus, the connections I have already been made here to save the time. LED blink. What happened? Hmm. Now it is getting open. So this diagram, last session also we have seen. So make a little zoom to your screen. So this is what the simple diagram I have constructed. That is, I have used this PIC 16F877A, and two LEDs I have add to the port B. So as we have gone through the pin description, so 5 ports are there in this A, B, C, D, E. Each one's capacity also we have gone through. That port A is having 6 bit, port E is having 3 bit, and the others are having 8 bits. So like that the distribution is. So here they have combined that the all B port, C port, D port, A port, E port, like that. So two LEDs now we have connected to the port B. So here also, while writing the program, so we will now go towards the program. So before going for the program, so what is this? The first configuration part, that is I have highlighted here. So these are nothing but the configuration bits are set. So in this you can observe only 2 bits are on. One is boron and another is the WDT. Is it? So how I have made that? So here also you can observe below is the output window. Here it is the editing window. Here that is the files, that is the function window, and the above one, that is the files window. So like this the four main major uh, compartments are there on the home page of this MP Lab software. So that we're supposed to just check out here. One we can observe, that is the configuration bit. So the same option is available from window. What it was told to you in window, where to click? Anyone is remembering? Debugging, web id tools, and pick memory view. In that, this configuration bit, so if we are clicking on this, so the same window it will open over here, so through which we can make a changes. And here if you are able to see the cursor here, generate source code to output. So if you are clicking on this, so definitely this code is getting replaced by this whatever we have set, on off, whatever it is there, so that will be getting replaced over here. Got it? So this is what this particular config code we have to add in the program. So this code can be after this xc.h or before xc.h, no issue. Because these are the global variables. So global variables we can define outside as well as the inside also. Is this Aishwarya allowed deny entry? So this is how we can do for this particular configuration bit. Got it? Now we will go for the actual program. So first statement is to define the frequency. So how to write? So that is also the some syntax now in C onwards. So we are going to refer the C only. So underscore crystal, that is xtel, again underscore freq space, and whatever the frequency you want to set. Now here which mode it is chosen? HS. आणि एच एस साठी आपण बघितली होती की 4 मेगाहर्ट्ज किंवा 8 मेगाहर्ट्ज किंवा 20 मेगाहर्ट्ज फ्रिक्वेन्सी नॉर्मली घेतली जाते. सो फ्रॉम दॅट इट इज टेकन how much it is? 8 megahertz. It is been chosen over here. So next that include this header file and the main program over here. So if you are observing, only this much is the program whatever I have highlighted. So while writing the program, say 80% it is similar the syntax to that of your C programming. Integer main bracket curly bracket starting tris b0. So we have to compare with the diagram. पहिला जो एलईडी कनेक्ट केलेला आहे तो RB0 ला कनेक्ट केलेला आहे आणि दुसरा एलईडी कनेक्ट केलेला आहे तो RB1 ला. इज इट? तर त्याप्रमाणे कोड लिहावं लागतं. तर इफ यू आर लुकिंग हिअर TRIS म्हणजे ट्राय स्टेट बफर विच बिट B0. RB0 ला इथं B0 फक्त लिहावं लागतं. इथं नाव ऍक्च्युली त्यांनी दिलेलं आहे. पिन आउट डायग्राम वर पण आपण बघितलं की प्रत्येकाला RRRR लावलेले रेजिस्टर, पण इथं फक्त B0 B1 B2 असं घेतलेलं आहे. सो इट इज सेट टू द 0 आणि 1. तुम्ही 8051 जर आठवत असेल तर की पिन जर आउटपुट म्हणून वर करायचे असेल तर 0, इनपुट म्हणून वर करायचे असेल तर 1, हे पहिल्यांदा सेट करावं लागतं. तर तसं इथं हे सेट केलेलं आहे की B0 ही पिन आउटपुट पिन म्हणून वापरलेली आहे, म्हणजे आउटपुट ह्या एलईडी ला जाणार आहे. बरोबर? त्यामुळं ही पिन आउटपुट म्हणून डिफाईन केलेली आहे, एकच पिन केलेली आहे. एवढं जर लक्षात ठेवा, बिकॉज वी हॅव टू वर्क ऑन द सेम प्रोग्राम. त्यानंतर व्हाईल 1 काय करायचंय की RB0 इज इक्वल टू 1, म्हणजे ऍक्च्युअल ही पिन RB0 इज इक्वल टू 1 म्हणजे ह्या एलईडी ला 1 मिळणार. आणि ऑलरेडी सेकंड कॅथोड इज कनेक्टेड टू ग्राउंड, म्हणून हा एलईडी ऑन होणार. RB0 इज इक्वल टू 1. तर कमेंटला डबल हॅश करून इथे डबल स्लॅश करून इथे लिहिलेलं एलईडी ऑन. त्यानंतर डिले इन्सर्ट केलेला आहे. MS म्हणजे मिलीसेकंद. किती मिलीसेकंद? 1000 मिलीसेकंद, दॅट इज इक्वल टू 1 सेकंद. इथं तसला कोड वगैरे लिहावा लागत नाही, जो आपण 8051च्या केसमध्ये बघितला होता असेंब्ली लँग्वेज मध्ये. तर इथं डायरेक्ट कमांड आहे, डायरेक्ट इनबिल्ट फंक्शन आहे डिले MS. किती ते तुम्ही तिथं चेंज करू शकता. तर 1 सेकंदचा डिले दिलेला आहे. त्यानंतर परत काय करायचंय? RB0 0 करायचा आहे, म्हणजे ऑफ करायचा आहे तो एलईडी. परत डिले द्यायचा आहे आणि रिटर्न 0. सो दिस प्रोसेस इज गोइंग टू बी वर्क कंटिन्युअसली. व्हाईल 1 म्हणजे कंटिन्युअस लूप मध्ये हा कोड लिहिलेला आहे. गॉट इट? So after writing this code, if you can see the cursor, we have to click on this one, clean and build project. जर काही एरर असतील तर तो एरर चेक करतो, आणि जर नसतील तर हेक्स फाईल तयार करतो. So this is how we can do. And here in output window you can check the respective. Now it is a little slow. So now you can observe here, clean successful, and it is trying to build a hex file. Build failed. It shows here why. Now we supposed to check out that what the error. Clean is successful, but while building it is just showing that the error So what is that error? C142 error function hash main redefined. So what is this error that we supposed to check out? Build dash config failed. So this error finding and error correction, so that is also one of the tasks to the programmer while writing a single space, or that syntax error is also giving a much headache to compilation. But here, instead of just wasting the time in this finding out that, definitely I will tell afterwards that okay, what was the error. So already the hex file is ready with us without any wrong in this. Yes, I will check it and I will tell to you okay, what was the problem in this. And then we will just added the hex file to this particular pick. And after the adding, the normal process, that is the debug and start. Here also it is giving the error. Why? Unable to open hex file. So I think that error we supposed to, here hex file it is not found. So compulsory we supposed to just make it that correction. You just wait a while and just stop the sharing. Mm, the code I will just replace. Okay, I got the error where I made it wrong. I will just will tell to you. So what I was done, okay, in the same file I have added the some additional programming also. That is here, if you can see in source file led1. So this is the program which I want to show it to you. But additionally some other program also I have done here, and that file also I have added in this. So the hex file, it was not getting by the software that which actually the file has to be connect to the this project, and the hex file has to create, and due to that only this particular error was came there. But I have removed that another file from this source file, and now only one file is there. And after that if I build here, so it is not giving any type of the error. and now it is just build successful, and the hex file is also going to be prepared there. So this hex file now we supposed to add over here in Proteus. Okay, so how to add? So double click on that. This type of window it will open, and program file. So from here we supposed to give the path. So here it came. So the path where this hex file resides, so that is also very important. So all of you just note down that it is available in the whatever the project title you have given. So how to write project title? In that dist folder, in that default folder, in that production folder, and in that production folder this hex file resides. So this automatically it comes. I have not prepared this dist or default or production, but you should know that. So that is important to remember or note down. हेक्स फाईल कुठून घ्यायची, पाथ कुठून द्यायचा, तर तुमच्या प्रोजेक्ट फोल्डरमध्ये dist फोल्डरमध्ये, डिफॉल्ट फोल्डरमध्ये, प्रोडक्शन फोल्डरमध्ये ती हेक्स फाईल असते, तर तो तिथून पाथ तुम्ही द्यायचा आहे. सो दिस इज व्हॉट आय एम गिव्हिंग ओव्हर हिअर. देन ओके. आता हे झालेलं आहे, सेव्ह केलेलं आहे, आणि नंतर डिबग स्टार्ट. So it will not now give the error, and run simulation. So you can observe here that this particular LED for 1 second it will be off, it will be on, it will be off, it will be off. Got it? So this is what how the process is there of a programming. So with a simple program we have seen. Now the next task what we are going to do, two LEDs I have connected, but only one LED it is on off on off. Now to make the another LED also glow on off, what the changes we supposed to do in the program? So that is what I want to ask to you, and accordingly we will make the changes. कुठे कुठे changes करावं लागेल, काय काय changes करावं लागेल. So the diagram is in front of you. की RB0 ला एक LED कनेक्ट केलेला आहे आणि RB1 ला दुसरा LED कनेक्ट केलेला आहे. So accordingly now D2 also we have to made it on off. ही पहिली टास्क. दुसरी टास्क, ज्यावेळेस D1 ऑन होईल त्यावेळेस D2 ऑफ झाला पाहिजे, ज्यावेळेस D2 ऑन होईल त्यावेळेस D1 ऑफ झाला पाहिजे, म्हणजे रिव्हर्स प्रोसेस. दिस इज सेकंड टास्क दॅट वी सपोज टू डू हिअर. तर त्यासाठी प्रोग्राम मध्ये काय चेंज केलं पाहिजे, दॅट यू सपोज टू just think and tell me the steps in the chat box. Accordingly I will modify the program and we will just check out. Okay, so diagram बघून घ्या. म्हणजे डायग्राम मध्ये काय बघण्यासारखं, फक्त कुठं कनेक्शन केलेलं ते चेक करावं लागेल, आणि त्यानंतर मेन थिंग इज द कोड, की इथं तुम्हाला कुठं काय चेंज करावा लागेल. So I will just open the code here. तर हा वर्ड मध्ये ती फाईल मी कॉपी केलेली होती, ऑन ऑफ सगळे डिटेल. दिस आय विल अटॅच इन द स्टडी मटेरियल. तर हा आहे प्रोग्राम. तर ह्या प्रोग्राम मध्ये काय चेंज करावं लागेल, कुठं कुठं चेंज करावं लागेल, दॅट यू सपोज टू टेल मी. तुमच्या नोटबुक मध्ये पण लिहून काढा, अँड इन चॅट बॉक्स ऑल्सो you can give the suggestions to me, so that I will make the changes. I will update the program, again create the hex file, and again we will simulate the program in the Proteus. So just take 2 minutes and try to tell me. You can make a zoom and just see the code if it is not visible. Only where and what change we supposed to do. Just put your logic, try to tell. So if you are thinking of the syntax and all that, so the same syntax, whatever it is there, commands are written, the same commands we supposed to add, but what to write in that? So for that you supposed to put your logic, nothing else. I will make a little zoom for this. So can anyone suggest that what is to be added in this? So if you want to suggest me that, first you should get what is this program. So I have already been explained की पहिल्यांदा कुठली बिट वापरतायत ती तुम्हाला आउटपुट म्हणून पाहिजे का इनपुट म्हणून पाहिजे ती सेट केलेली आहे. त्यानंतर ती बिट 1 आणि 0 केलेली आहे. असा प्रोग्राम होता. आता फक्त मी काय केले तर अजून एक एलईडी त्यामध्ये ऍड केलेला आहे आणि तोही मला ऑन ऑफ करायचा आहे याच्याबरोबर. तर आपल्याला काय चेंजेस करावे लागतील? दिस इज द क्वेश्चन आय आस्क्ड. So if no one want to give suggestions, then I will go for that. ओके. तर पहिल्यांदा आपल्याला डायग्राम बघायची की हा जो दुसरा एलईडी आहे तो कुठं कनेक्ट केलेला आहे. सो इट इज कनेक्टेड टू RB1. जसं RB0 ला हा कनेक्ट केलेला आहे. So here only we will do. So RB0 ही पिन आउटपुट पिन म्हणून केलेली आहे. तसंच आपल्याला RB0 पिन म्हणून आउटपुट म्हणून सेट करावं लागणार आहे. जस्ट आय एम जस्ट कॉपी and paste the same code, but here B1 एवढंच करायचं आहे. So definitely this will become RB1. ही एक लाईन ऍड करावी लागेल इथे, प्लस ऑन आणि ऑफच्या वेळेस अजून एक सेम कॉपी पेस्ट आपल्याला करावं लागेल. जसं RB0 1 केलेलं आहे तसंच RB1 पण ऑन करायचंय आणि इथं RB1 0 करायचंय. इट विल बी ऑफ. संपलं. फक्त 3 लाईन्स ऍड करायच्या आहेत. दॅट इज ओव्हर. दॅट इट विल गिव्स द appropriate output whatever we need. So let us see. I will just copy this now code and I will put in the this instead of this from int main I will replace it. Okay, now save and debug. So here build successful. That means no errors are found. म्हणजे सिंटॅक्स एरर काय नाही आहेत, परंतु लॉजिक बरोबर आहे की नाही जोपर्यंत आपण सिम्युलेशन करून बघत नाही तोपर्यंत आपल्याला समजणार नाही. सो आय विल क्लिक ऑन दिस क्लीन अँड बिल्ड प्रोजेक्ट so that the hex file clear and the creation of hex file will happen. So that hex file is prepared. Now again double click the same path we supposed to give, make it okay. then debug, start, then debug, run simulation. And now you can observe both the LEDs are at a time start glowing and off. So if anyone has tried in their notebook, so definitely it's a good practice that those who are interested in the programming, writing the codes, so definitely this will be helpful in your projects and other things also. Okay, so in this way how we can simulate this particular blinking of LED by using the pick. Now the second task I was given that, so for that at least can anyone give the suggestions, so that I want to see की D1 ऑन असताना D2 ऑफ पाहिजे आणि D1 ऑन असताना D2 ऑफ पाहिजे आणि D1 ऑफ असला की D2 ऑन झालं पाहिजे. So in that way, so what the changes we supposed to do in the program. So again take 2 minutes, I will wait, otherwise I will give the solution for the same. अल्टरनेटली ऑन ऑफ झाले पाहिजेत, तर काय करावं लागेल, कोडमध्ये काय चेंज करावं लागेल. So directly we will make here the changes. Okay, so still no response from your side. So I will just tell here की एक LED ऑन असताना दुसरा आपल्याला ऑफ पाहिजे. So definitely we only supposed to make it 0. हा ऑफ असताना हा ऑन करायचा आहे. So this is the only change we supposed to do it here, and then we will just create the hex file for that. So build successful, and you just check the same over here, that is for simulation. So now you can observe that alternatively they are on off. So this is how the once the logic you will get clear. So definitely the what changes and where the changes we supposed to do, that we can understand. So this is a primary level basic program. So still we supposed to check out the instructions, which are the 35 instructions and how we can write the actual program. But for building your logic, so this simple demo I have shown to you, that for the LED blinking by using the pick. So I hope you understand now the logic and the instructions that definitely in the coming session we are going to learn. So this is the how we can interface or we can communicate with the external peripherals by using this particular pick that I have tried to show. So I hope the whatever we have learned today, so all of you got. So you also just go through once again through the video as well as the PPT, whatever I am going to attach over here, and you will be easy for the next session. Okay, so now I'm going to stop sharing, and you can just add your attendance to this particular chat box, so that it will be better for me put your attendance. Okay, so now I'm going to mute myself. So thank you. साळुंके ना. हॅलो विजय साळुंके, आर यू देअर? अहो आत्ता जॉईन
येस सर.
होताय तुम्ही? हा, लेक्चर झाल्यावर? बोला बोला काय.
हो सॉरी सर, मग
अरे 11:30 वाजले.
लक्षात नव्हतं सर.
अरे काय मग सकाळचं पहिलं सेशन पण मिस केलंस का तू?
हा, मला वाटलं 11:30 चालू आहे आता, म्हणून मी विचारलं.
अरे मित्रा, 11:30 ब्रेक असतो, लंच ब्रेक.
अच्छा.
चला लक्ष द्या, व्यवस्थित अटेंड करा, अब्सेंट राहू नका.
हा सर.
किती लेक्चर अटेंड केले तुम्ही आतापर्यंत माझे सांगा बरं? हार्डली एखादं दुसरं लेक्चर अटेंड केलंय
नाही,
डिफॉल्टर लिस्ट?
जास्त
चार
केलं सर.
पाच, 10-12, 15-20, जास्त म्हणजे असे किती? डिफॉल्टर मध्ये आहात तुम्ही. डिफॉल्टरचं मेसेज सुद्धा आता पालकांना जाईल तुमच्या.
करतो
अहो
सर.
हे जे अटेंडन्स नंतर पकडणार आहे तो, तुम्हाला वाटेल की हे ऑनलाईन चालू आहे, कशाला काय हे होतंय, पण तसं नाही आहे. हा
करतो सर.
हा, उगा आम्ही तुमच्या पालकांना फोन करायचं, परत पालकात तुम्ही काहीतरी त्यांना सांगणार, परत आपल्यात मिसकम्युनिकेशन होणार, तर असं नका होऊ देऊ. ऍज अ सीसी माझ्याकडनं रिक्वेस्ट आहे तुम्हाला की याच्या पुढचे सगळे सेशन्स सगळ्या सब्जेक्टचे अटेंड करा.
हो सर.
चालतं, चला.